If you've landed here, you're likely looking for help with your GO95 compliance. Great news, we can take that one-time data collection and turn it into assets across your entire organization. Let's take a look at the data and see exactly how we do that. Here is a 3D environment created by one of our field teams. We were able to take their LiDAR data and process it, then run it through some of our in-house software and process to extract measurements and features. So if we look over here, we start with our pole height. Our pole height is 36.72 feet based on measurements. It is a class 3 Douglas fir pole. We know it is a 45-foot pole. Sometimes that is identified on the birthmark or on a metal tag. Sometimes it's just math. And then we've got our pole owner identified. If we go down to our pole tag, we've got this annotation down here. Pole ID is 29274. It is a metal tag, and if we want to verify that from some of our RGB imagery, you can see here 29274. Have a few photos of it. Have our latest pole integrity inspections. You can see Osmos with their different inspections that they've performed. And so now what we do is go through and do some manual QC and verification on it. We want to identify who our attachers are. So our top attachment, you can see we are at an attachment height of 23 feet even, and that is Imperial Valley Telecommunications. It is a 48 fiber cable, single cable, meaning it is not bundled. It is lashed together on a 1/4 inch messenger cable. And the support structure connecting it to the pole is a dead end plus a 3-bolt clamp. And again, some of our RGB imagery that comes in to help us out with that. For to cycle through here, shows us here our top connection has a dead end as well as a 3-bolt clamp. A down guy of 3/8 of an inch. Again, we can see that here. And then we can go through some of our other attachers. Our bottom attacher here is going to be Charter Spectrum. They have a 96 fiber and a 144 fiber cable bundled. Again, bundled on a lashed together on a messenger cable 1/4 inch. Again, if we go to take a look at that, you can see here, here's our 144 fiber cable, our 96 fiber cable. It is lashed together on this messenger cable. Again, with a dead end and a 3-bolt clamp, and its attachment height is 21.13 feet. So all of this information helps us to go in and create a pole profile to run pole load calculations on, whether that be through OCalc or Spidacalc or PLS CADD. We can also take this information with our LiDAR data as well as our visual data, and we can see here things like compliance pieces. If we look down here on our 4 down guys, so we have a down guy up here on our electric circuit. We also have 3 down guys, one supporting each of the joint use attachers. So if you look here, our bottom joint use attachment has a sleeve, our middle does not, and our top attachment support does have a sleeve. Now, crazy enough, you can actually see this in the LiDAR data, how it looks a little thinner on this wire, so we're able to make an annotation and say there's a guy sleeve missing. That is a very low priority deviation, so it's just something we would report. Doesn't need immediate remediation. So it's just something to monitor next time you're out on patrol or have a qualified worker out there doing it. You can go ahead and re-sleeve that down guy. Again, if we want to look at different spans to ensure that our lines are connected and we can see what our average cable span length is, we can do that here. We can see how we attach to the next structure and even look down. All the way down this line here. And same thing, if we wanted to cross the street here. Now, it doesn't look like we have any joint use attachers going across the street, but if we did, we would run that here. You can see how the wires kind of sag a little different, likely because instead of having a ton of tension on it, that it is just a slack span. Again, those are factors that go into your pole load analysis. Same here, you can see how low this sags. So these are all factors when running our pole load calculations, how we get to our answers. So if we go back over here to the pole that we have annotated, okay. Another quick run through. Another measurement feature we've got here is our crossarm at 10.03 feet. So we know this, this is a 10-foot crossarm. And it is a dual crossarm with dead end insulators on this side. Again, you can see it in the point cloud, but it's also something that you can visually see as we go through our images here. We have dead ends going to our bell insulators and slack span to our next pole. So these are all features that we use to properly run pole load calculations. But the best part about our data is it doesn't serve one purpose. You have access to a point cloud, you have access to photos, so you can verify whether or not you are in compliance with making sure you have tags on your attachments. So you can see here our top attacher has a tag, but it's pretty blacked out. Our middle attacher does not. Our bottom attacher does not. So we know that all three of these would be out of compliance with having tags. So as you can see, there are several different ways that we can use this data across different departments to satisfy everybody's needs, from GO95 compliance to engineering analysis, asset management, updating your GIS systems, any kind of planning, and long-term grid strategy. If we've piqued your interest, click down below, let's book a demo and see how we can apply everything that you just saw to you and your company.